Hey everyone, doing problem 15 for the chapter 11 review on page 785. We're evaluating the series to test for divergence or convergence of n equals 2 to infinity of 1 over n times the square root of the natural log of n. So right off the bat, I recognize that this looks like some integration that we actually could do. Usually that's a more difficult test, but this might actually be an easy integration. So if we consider the integral from 2 to infinity of 1 over x times the square root of the natural log of x with respect to x. And then, of course, we'll be taking the limit as b approaches infinity, the integral from 2 to b of 1 over x, square root natural log of x, dx. We can do a u substitution. So if u equals the natural log of x, du equals 1 over x dx. We'll also change our bound, so u of b equals natural log of b, u of 2 equals natural log of 2. So plug that in. Natural log of 2, natural log of b. We end up with 1 over the square root of u with respect to u. From here, we can treat this as still taking the limit. This is really u to the negative 1/2 du. So taking that integral, we add 1 to the exponent and then divide by it. So dividing by positive 1/2, we'll just get 2 times u to the exponent plus 1, so that's positive 1/2 on the bounds of the natural log 2, natural log of b. So this is also just 2 times the square root of u. Once we plug in our bounds, we'll have 2 times the square root of the natural log of b. Still taking the limit as b approaches infinity. Minus 2 times the square root of the natural log of 2. Once we plug in infinity, we've got 2 natural log of infinity minus 2 times the natural log of 2. So this is a continuous function. Despite the square root and the natural log, it's still going to approach infinity, so we have infinity minus a value, but infinity minus something smaller than infinity is still just infinity. So since the integral diverges, we can say then that our initial sequence, or series rather, diverges by the integral test. And that's our final answer.